Okay, last page of our Algebra 2 Unit 11 for CP classes review. Okay, let's start with number 25. We want to find the geometric mean of each pair of numbers. Remember, the geometric mean of the numbers AB is equal to the square root of AB. So we want the square root of 3 times 27, which is equal to 9. Or, here I want the square root of the square root of 5 times the square root of 45, which is not pleasant, but I can simplify the inside. Okay, that's the square root of 25 times 9 because 5, right, 45 is 5 times 9. Okay, so I'll make a little note, that's 5 times 9. Okay, so I can take the square root of 25 and the square root of 9. I take the square root of 25 and the square root of 9. I get the square root of 5 times 3, or, simple enough, square root of 15. That's your geometric mean. Okay, insert the given number of geometric means between the pairs of numbers. Okay, well, 1 and 729, we want 1, and we'll do it this way, 2, we want 2 of them, 729, as it tells me t sub 1 is equal to 1, and t sub 4 is equal to 729. I need to know what r is, so let's find out r. Okay, so t sub 1 is equal to 1, t sub 4 is equal to 729, and I know t sub 4 is equal to t sub 1 times r to the 4 minus 1. Okay, so our 729 is equal to 1 times r cubed. That's the cube root of 729. That's what we want to know. Cube root of 729 is what? Let's figure that out. 7 to 9, take the cube root, it is 9. Okay, so r is equal to 9. Multiplying by 9, that makes this number 9, and that makes this number 81. Those are our two geometric means. Similar concept here. We're given 1 over 36. We want to find 1, 2, 3 geometric means between 9, 1/36, and 9/4. So it tells me t sub 1 is equal to 1 over 36. Also tells me that t sub, what do we have? 1, 2, 3, 4, t sub 5. T sub 5 is equal to 9/4. Okay. And so t sub 1 is equal to 1 over 36. T sub 5 is equal to 9/4. We also know the formula, which is t sub n is equal to t sub 1 times r to the n minus 1. So we get 9/4 is equal to 1 over 36 times r raised to the 5 minus 1, or 4. Okay, I'm going to multiply both sides by 36. Okay, 4 goes to 36, that's 81 is equal to r to the 4th. So I get 3 is equal to r. Alright, so that's good. That means I multiply by r, so I get 3 over 36, or 1/12. Times 3, I get 3 over 12, or 1/4. Then I get 3 over 4. So again, that's 1/12, 1/4, 3/4 are three geometric means between there. Okay, write each series in expanded form. Okay, so that's 2 times 1 minus 3 plus 2 times 2 minus 3 plus 2 times 3 minus 3 plus 2 times 4 minus 3 plus 2 times 5 minus 3. Okay, I'll slide this over a little bit. Make sure I have enough room. Okay, and then I just simplify each of those pieces. That's -1 plus 1 plus 3 plus 5 plus 7. So that's what that's equal to. Similar thing here, except we're starting with 5. So starting with 5, that's -1. -1 to the 5th over 5 plus 2 plus negative 1 to the 6th over 6 plus 2, plus negative 1 to the 7th over 7 plus 2, plus negative 1 to the 8th over 8 plus 2, keep going, plus negative 1 to the 9th over 9 plus 2, plus negative 1 to the 10th over 10 plus 2. Simplify each of those. That's negative 1 over 7 plus 1 over 8 minus 1 over 9 plus 1 over 10 minus 1 over 11 plus 1 over 12. Okay, write each using sigma notation. So first off, we have to do is see if it's arithmetic, geometric, or neither. That's arithmetic. So I can use my formula to find my common term. Okay. So arithmetic, t sub n is equal to t sub 1 plus n minus 1 times d. And n sub 1 is 1. N minus 1d is 4. We're adding 4 each time. Right? Go there to there to there. We're adding 4. So t sub n is equal to 4n if you simplify that. Okay. Now I also know that 100 is equal to 4n, which tells me n is equal to 25. So I have my two pieces, n, t sub n, so I can figure out my summation. So that's n is equal to 1 up to 25. Okay, so this one's geometric. Geometric, that one's pretty straightforward. Let's make sure we do it right. T sub n is equal to t sub 1 times r to the n minus 1. Let's make sure we get everything right. Okay, t sub n, so t sub n is equal to 10 times 5 raised to the n minus 1. Okay, and that tells me, oh, I don't know where I got 10 from. That's supposed to be a 2. 2 times 5 raised to the minus. So I want to find what n is for t sub n. So if I know 2 times 5 to the n minus 1 is equal to 2 times 5 to the 15th, that tells me n is equal to 16, because I just pay attention to the n minus 1 and the 15. That means n is equal to 16. Okay, so I've got n is equal to 16, I've got t sub n, so I can write my generic form, my summation, n is equal to 1 up to 16 of 2 times 5 to the n minus 1. And I put the whole thing in parentheses. Oh, life's a little bit easier here because this has got infinity. So I just got to find my generic term. Oh, a little bit harder. The top is just n, right? If I look at the top, remember I talked about these in class. It's easier to break it down in terms of top versus bottom. Okay, and notice the bottom, these are odd. Odd usually follows the form 2n, either plus 1 or minus 1, depending on how we go. So we'll check it out. 1, 2, 3, 4. Okay, the top is 1, 2, 3, 4. So for n, that's just n. That's the top. The top is n. Okay, for the bottom, it's 3, 5, 7, 9. That looks like 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1, 2 times 4 plus 1. Okay, so that works out. That makes it 2n plus 1. So I can write my generic summation from n is equal to 1 to infinity. The top is n, the bottom is 2n plus 1. Okay, remember that's neither, so that's why we have to do that kind of work. And the next one's neither also. Okay, they're just counting by 1. So again, we want to break it down to the top and the bottom. Okay, so when n is equal to 1, 2, 3, 4, well, the top is 3, 4, 5, 6. It's 2 more than n. Okay, so that works. The bottom is 2, 3, 4, 5. So that's one more than n. So again, it goes to infinity. So n is equal to 1 to infinity. The top is n plus 2. The bottom is n plus 1. And there is our arithmetic sequence. Okay, so that's it for the review for Unit 11. Email me if you got questions.